Hello, today we are covering lesson 9.5, geometric series. You guys will be able to define geometric series and find their sums by the end of today. So once again, the sum means that you are basically taking a sequence and adding it up every term in the sequence to find the sum of the total thing. So we have our equation. You'll notice it's different from any other equation we have. We have the sum of n amount of terms equals a sub 1 times 1 minus r to the n over 1 minus r. So like the previous problems, we need to define what each of these means. A sub 1 is the first term in our summation. N is the number of terms we have, and R is once again our common ratio because we are dealing with a geometric series. So we're going to jump right into problem 1, find the sum of the series. So we need to decide what A sub 1 is, what R is, and what N is based on what we are given. So it might be easiest to simply write out the first few terms in our series. So you could plug in 1. You end up getting 2 times 1 in the end, because anything to the 0 power is 1. So our first term, which also helps us find our a sub 1, is 2. And also, to find our common ratio, we can write that out. We can do the same thing here. So our second term should be negative 8. We'll check our third term out real quick. Okay, so to find the common ratio, you probably only need to do 2, but I did 3. You take, say, 32 divided by negative 8. That gives you negative 4. You can also check taking negative 8 divided by 2. That also gives you negative 4. So our common ratio is negative 4. Our n value is the number of terms. Now this is similar to our previous lesson where we take our top number minus our bottom number and we add 1 to it. Oops. So we have 12 for our n. Now if you notice, our a sub 1 term and our r number happen to correspond with information given to us. I will say, depending on how our exponent is set up and how the problem is set up, that might not always be true, especially for this a sub 1 number. So you can check it. If you want, you could just assume that a sub 1 is that term in front of the parentheses being multiplied, and that r is what the exponent is the base of the exponent term. Or you can write out terms in your series and find them that way like we just did. Anyway, once you know what a sub 1 r and n are, you can plug them into your s sub n sum equation. So a sub 1 is 2. Notice the 2 is multiplied by the whole fraction, so do the multiplication step last. PEMDAS tells us we need to do parentheses and then exponents, and then multiply and divide. Okay, so we're going to simplify within the parentheses. We have negative 4 to the 12th power. Now notice, be careful with those parentheses. I included them on purpose. We end up getting a very large number. That is okay. So we have 2 times, all times I should say, 1 minus, because we still have this negative here. The negative 4 to the 12th did become positive, as you can see on the calculator. But we still have the minus from the rest of the problem. Whoops. We end up getting 2 times 1 negative 16,777,215 divided by 5. Finish solving this. We get 2 times negative 3,355,443. And so our final answer, is equal to negative 6,710,886. That is pretty big. So within 12 terms, our sum of these is a very large number. Pretty crazy. Okay, part 2, we are going to find the sum of this series. Once again, we can go ahead and plug in some info, starting with our first term. Notice you always start with this number down here. If it doesn't start at 1, you plug in whatever number is at the base. So we have 3 times 2, 1 minus 1, so 3 times 2 to the 0 power, or 3 times 1. So our first term, a sub 1, is equal to 1. We know our end term is 25 minus 1 plus 1, or 25. And our common ratio, let's solve out just a couple more to make sure that it is actually 2. Oh, I'm so sorry. This is not a 1. 3 times 1 is 3. Hopefully you guys caught that. 3 times 2 is 6. Here we go. Now we're back on track. Three times 4 is 12. So our common ratio is 2. 6 divided by 3 is 2. 12 divided by 6 is 2. So we have our a sub 1, which is 3, not 1. Our number of terms is 25, and our common ratio is 2. We can go ahead and plug this into our geometric sum equation. I already did the work out. 2 to the 25th power is negative 33,554,432. And it's all over negative 1. Don't forget to subtract the very large number from 1. So we get negative 333,554,432. 163,431 over negative 1. Divide, and you get the positive version of our numerator. And then multiply by 3. So our solution is 100,663,293. All right. That's all I have for you today. Have a great day.